Hey, I'm Suhaib. This project is majorly related to production-grade email scheduling system built for reach-block assignment. The major tech stack in being used here is we are just use front-end as Next.js and back-end Express.js, and it uses PullMQ for persistent job scheduling, Redis for queue coordination and rate limiting, and PostgreSQL with Prisma ORM for data persistence, and NodeMailer with Ethereal SMTP server for email delivery purposes. Let me just walk through the implementation, how it's been actually done. This is actually the code base. It's kind of mono repo structure. We got backend here and we got a front end here. In backend, we got source API in which middleware routes have been planned in here. And we got a worker which is having email worker and services, and queue system with the Redis line. Okay, so backend is again started with the 3001 port, and I've just started my front end of Next.js with 3000 port. Let me just go to 3000 port. All right, so this is 3000 port. This is the app landing page that I've actually built. It's just for demo purposes. We got this simple landing page which has some hero sections and how exactly this is gonna be needed and help for scaling purposes. This is how the main section flows. Then we got authentication part. When I just go to get started, it just asks for me for Google continue with Google option. For authentication, I majorly use passport.ts with the Google OAuth 2.0 strategy. On successful authentication, we use actually issue a JWT token, which is actually stored in HTTP only cookie for XSS protection. The front end uses this stand for client side auth and state management. Let me just show you real quick. As I can just go and continue with Google right now. When I click on continue with Google, it just asks for my account. I'll just select this account that I'm actually using for testing purposes. Okay, so authentication is successful. As you can see in the bottom layer, my account name as well as the profile icon is actually been fetched from my Google system, and it just shows in here. This is the major dashboard what actually been in here. This is the things that we got a simple sidebar, compose button, campaigns, analytics, contacts, and settings. In dashboard, we got sent, failed, how much sent, and how much failed. It's actually fetching from database and it's showing in here. This is the database, and I've actually used the upsplash Redis in here for queuing system. And then we got neon.db for more likely managing all of the things. We have used Neon as a above of the Prisma. We got a compose button here. How this actually works. The compose page is completely been with React with controlled form inputs. Recipients are passed from CSV or text file using a file reader API. This type safety form, we are using TypeScript interfaces for all states. Let me just create a new campaign for now. I'll just name it some weekly and just do it as demo data, something like that. And it just asked me for a list. It could be CSV or text. I just got testing format test recipients in which we got 3 emails, and just open that. It's been automatically thought that this is 3 recipients are actually loaded in here. I just need to select the time. I'll just do it for next minute and how much delay and hourly limit. If I just click on schedule campaign, and in backend we could see that these campaigns are actually been created in here. Post request is actually sent there, and we got all 201 responses. And also in this, we got the 3 scheduled in our dashboard. It just shows the status of scheduled in here. So when submitted, we call our API campaign services, which uses Axios for auth interceptor that actually catches the JWT from cookies. So this how exactly the backend logic scheduling has been happening in here is, on our backend we use Zord for runtime validation. We wrap everything inside a Prisma transaction in here. First creating the email campaign and record that, and bulk insertion individual email jobs with the scheduled timestamps that's been used in our Prisma query schema. I'll just show the campaigns.routes for you. In above we got this Zord schema validation. What exactly this is, we got a post handle here. This is how the Prisma transaction block takes place. Email queue. So this is how actually the queuing system actually works in here. Note that this is we are using PullMQ's delayed jobs, not cron. The job sits in Redis and automatically become active when the delay actually expires. So if I just refresh the page right now, this is actually been sent from scheduled. It's been moved into sent. Right now you can just see the time of 10:19. This is actually been sent. That's what actually the status shows in. These are the before jobs which actually failed. The latest jobs are be showing here, and we got the thing as well. The 12's been sent and 3 are failed. Okay. So this is how actually things are working in here. Now, for now, it just been set for 5 parallel jobs. In email worker, as we can see clearly that how the worker creation actually works in here with consistency. We got the config worker here, right? So this is how config worker consistency been happening here. Email, if the email job is scheduled, as we can see, if the email job is actually scheduled, then we can just say already processed, and it just says now we just need to check the hourly rate limit using Redis counters. The key format here is we just rate limit that on the basis of year, month, and hour. This ensures limit Redis queue system because jobs persist because Redis runs with append only. Yes, the write ahead logic, the Postgres stores the source of truth. When I restart the backend bullMQ in here, it actually reconnects and job resumes with the remaining delays without having any problem in there. This is how actually things been done. Actually, we got the rate limiting under load as well. Let's just demonstrate the rate limiting. I'll just send the hourly limit. Let's just talk about the trade-off and assumptions in here. Trade-offs are made with Ethereal SMTP for safe testing. There is no real image sent yet, and we got the rate limiting uses hourly windows. And a sliding window would be smoother, but it would be more complex too. The worker runs in the embedded with API process. In production, we could just separate it with the horizontal scaling. And I'll just choose the per user rate limits. We'll be having the global rate limit for, like, if we just got a multi-tenancy support purpose. We build the system actually. Thanks for watching.